Hey students, it's your favorite instructor here, and here is your first lecture for GIS 103. We are covering the basics here, what GIS is, what geospatial data are, and what the different data models are. And we're going to jump right into it without further ado. So here we go. I'm going to bring up the slides. And so we're only going to do 3 slides here. I like to keep the slides pretty simple. And so the first slide is, what is GIS? Well, the big joke is that GIS people will make is GIS stands for Guaranteed Income Stream. I think it's funny every time we say it, but it's actually not that far off. If you have GIS skills or if you understand the concepts behind GIS, it really does make you more hireable, and it's something that employers do look for. And so even if it's not something you're wanting to go into to focus on primarily, if you can know your way around GIS software, it really does improve your hireability, and it's not a joke. When I first started at the Forest Service, we did most of the GIS for all of the other specialists, so your soil scientists, your civil engineers, things like that. And over the past 15 years, that has definitely changed. They are now expected to do their own GIS, and now the GIS specialist is expected to do more complex tasks and to help troubleshoot when maybe the simpler things aren't working for those people, but they are expected to be able to do a lot of their own analysis and to make their own maps. So it's changed as it's become more and more prevalent in the industry. But it does stand for actually Geographic Information Systems. And so technically a map, just a regular paper map, is technically a GIS because it is a Geographic Information System. But when we use that term, we're referring to more of a specific brand of software or a specific discipline. And so you're going to see that developed here as we go through this lecture. And so what is geospatial data? Well, GIS uses geospatial data, and essentially the answer I'd be looking for from you guys is geospatial data really are any data that are tied to a real world location. So if it's And I mean, you could say, a universal location, even if we were doing like the surface of Mars, but let's not get too far afield on that. Essentially, if the data you were looking at, if they're trying to symbolize something that is in the real world spatially, then we would say that that's geospatial data. And so it can take lots of forms, but something that makes GIS special, as opposed to something like a CAD drawing or like a computer-aided drawing, is that GIS actually contains topology. And so when we use that term, we're not talking about like land topology. What we're talking about here is that every feature within the GIS knows where it is spatially related to every other feature in the GIS. So every feature in the GIS knows where it is in regards to other features, and those features know where they are in regards to that feature. So it knows exactly what direction, how far it is from everything else that's around. That's unique to GIS data and the GIS system itself. And you can tell that makes it very powerful because it makes it so you can then begin to ask it questions about how far apart things are, how many of these are within a distance of this, those types of questions, which used to be very difficult to answer with a paper map. We then have spatial data versus tabular data. So spatial data would be something that's represented something in space or direction and distance from one another, where tabular data would be something in a table. And what's another thing that makes GIS special is that every feature in the GIS has both a spatial component to it and a tabular component. So every feature that's on there has a record in a table. And so that's where something, if we had like, for example, a room full of students, we could have the spatial side would be which row they're sitting in and which chair they're sitting in, where the tabular side would be like what their 918 number is, what their major is, what their hair color is, their height. And so you can see when those are combined, when each student would have a record in the table, we can then start asking really complex questions, where how many students under 5'2" are also health science majors that sit on this side of the room. So you can see I'm starting to combine tabular questions with spatial questions. And so that's the real power of what you're going to see here in GIS. It could do way more than even that, but that's just a really, really strong use case for it. So then we're looking at here, and what are the two geospatial data models? So this would essentially be if we had a feature or something in the real world, say a stream, what are the two ways we could represent it as geospatial data? And so on the next slide here, you're going to see that those two models, they sound really fancy smancy, and so you can tell your mom what you learned about today, that, you know, when she asks you when you get home from school, you can say, I learned about vector data and raster data. No big deal. But they have cool names. They sound a lot smarter than they probably are. But in this slide here, I created this slide to show you just how we'd represent something. So here's a stream in the real world. Say this was a picture of a stream. We could represent this stream using the vector data model, which is the middle one here. And that essentially uses points, lines, and polygons. So if you use enough little vertices and you connect them up with lines, you can actually get a very realistic representation of that stream. But it's not perfect. So neither of these two data models is better than the other. Really what happens is it's really just determined by the purpose of your map. And so the vector data model, the power of that is because it's using points, lines, and polygons, it actually is a feature. It knows I am representing the Sprague River, or I am representing the Williamson River. And so that's the big power of it, is you can then start asking, well, how long is the Williamson River? How far is it from this? How far is it from that? So actually in the industry, the vector data model is more common, but I'm not saying it's the better of the two models to use. It's just more common because it answers the more common questions. So if you were looking at an agency like the Forest Service or the BLM, which stands for Bureau of Land Management, or Fish and Wildlife, it's not using they use the vector data model probably 80 to 90% of the time, but it's not because the model is necessarily better. It's just that their types of questions are going to require this model. So they care more about like acreage of wildland fire or streams or roads, miles of road. Those questions are answered with the vector data model. Now the raster data model, the one on the right here, what it's doing is it's just a bunch of cells, and each cell has a value. And so you can see the blue cells would be saying I'm water, and the green cells would be saying I'm land. What you lose there is that it doesn't know it's the Sprague River. It's not a feature. It's just each cell knows what it is, but it doesn't know it's part of a larger concept. And so you lose that ability to ask, well, how long is the Sprague River? Because it would not know what the Sprague River is. But you could start asking things like, what's the average precipitation in this area? What's the average slope in this area? The raster data model is really powerful for those types of data. So a group like the USGS, U.S. Geological Survey, most of their data would be raster because they're going to be using soil data, precipitation data, land cover data, things like that are going to be much better for the raster data model. Now, in this class, you're going to be using mostly vector data, but there are two classes at OIT that do focus exclusively on raster data, and they're just manipulated differently in the software. And so you should be good at both, but you're going to probably use vector a bit more. And we'll go to the last slide here. And so in the last slide, these are just vector data types. And we'll get into raster data types a bit later in the class. But you can see here I did a Venn diagram on the left. And so any vector data set is known as a feature class. I'll repeat that. So any vector data set, so if you give me a data set of geospatial data, and if it's using the vector data model, so points, lines, and polygons, it's known as a feature class. And then we have inside the Venn diagram here, we have shapefiles. So that's a type of feature class. So shapefiles are very generic type file, and they're very simple. But what they actually are is 5 to 8 separate files that work together as one file. So if you were to look at them with your Windows browser or File Explorer, you would see, say that our file was named River, you would see like 5 to 8 different files named River with different extensions on the end of them. So it'd be river.shp, river.shx, river.aux, things like that. But they're all working together as one file. So if you looked at them with the GIS software, you would see them as one file. And so that's a shape file. That's an example of a feature class. It's a very common type of feature class. But it's important to know that all shapefiles are feature classes, but not all feature classes are shapefiles. There's other types of feature classes. But because it has the word feature in it, that should tip you off that all feature classes are vector data. Okay, so if I have a geospatial data file and it's in the vector, using the vector model, then I know it's a feature class. Now there are some rules here with feature classes. Feature classes must contain the same geometry. So that means my feature class, if it's a point feature class, it has to only have points in it. In fact, it only will allow you to have points in it. And if it's a line feature class, same rule. Polygon feature class, same rule. Now there's a best practice rule that the software will let you break, but if somebody saw you doing this, they would think you didn't really know what you were doing. And so that would be if you mixed up your feature types inside your feature class. And so if I had a feature class that had roads in it and also streams, they're both line features, so I could do that. But somebody who saw you doing that would think you probably didn't know what you were doing, because you really need to keep the same types in each feature class. So I need to have a feature class for my roads and a feature class for my streams or rivers. Now I could put rivers and streams, like smaller streams, in the same feature class because they're both water bodies, but I wouldn't want to put roads in there. Now you can break that rule a little bit if you have like a points of interest feature class, or maybe you have campgrounds and mountain peaks and trailheads. Those are all point features, and because they're all points of interest, they get a little bit more miscellaneous. But typically you want to try to keep it so that there's a theme to each of your feature classes. So now the last thing that we'll talk about here is the geodatabases. And so geodatabases here on the right side, I wrote down the 3 types of geodatabases. All a geodatabase is a container that holds geospatial data. And so geodatabases, there's 3 types here. There's a file geodatabase, a personal, and an enterprise. And so essentially, the file geodatabase is one of the newer types. It has no storage limit, but you cannot access the geodatabase using other database software like Microsoft Access. It's really just meant for using in GIS. Where a personal geodatabase, it has a storage limit. These aren't quite as common anymore, but their power is if you have really complex database rules, you can manipulate them using database software and set up those rules like Microsoft Access. And where an enterprise geodatabase is essentially one where you're working with a team that might want to all access the same data at the same time. And so it actually checks the data out for you. And so if somebody makes an edit to it, and then you can bring it back and it can harmonize all of those types of edits. So you're not getting into these locking things where 2 people are trying to work on the same thing at the same time. It'll lock them out. Enterprise databases are made for sharing data with large groups. And so like a company might set those up for their data. And now geodatabases do contain feature classes. So it's just a container, but inside of it, I can store my feature classes. And that allows me to set up more advanced rules and computing type ideas rather than having my data just stored as a regular shapefile. And I want to leave with this is that this is one of the 10 commandments you'll hear in here, is that thou shalt never refer to your geodatabase containing shapefiles. Geodatabases do not contain shapefiles, but they do contain feature classes. So as soon as I import a shapefile into a geodatabase, say I had a rivers shapefile and I put it in my geodatabase, that's no longer a shapefile once it's in the geodatabase. We call it just a regular feature class. And so the quickest way to not get a GIS job is if you make a mistake by saying your geodatabase has shapefiles in it. Any GIS person is going to know that that means that you're really just beginning, because geodatabases never contain shapefiles. Only folders contain shapefiles. And you'll see that more when we get into the labs, is that you'll see the difference between feature classes within a geodatabase and feature classes that are shapefiles. So I just want to hit on those topics for this first lecture. I hope the class is going well for you guys, and I will post this, and we'll just keep fighting the good fight. So that's what I've got. So as always, this has been your favorite instructor, Ethan Howard, and laters on the men, Jay.
Laters on the men, Jay.